Okay, I want to quickly talk about two advanced routing tips that you may need to use in your project. The first is using a via to connect one side of the board to the other, and I just want to walk you through a very simple example. And the other is using a larger 0 ohm resistor as a way to route traces on one side of a board if they might have to intersect. So you may put a part on a board and another part, and it turns out that you need one trace to go under the other, which is impossible on a single layer board unless you add in a footprint that looks like this, but is larger. And we put a 0 ohm resistor, which is just like a wire, but it's a physical part that's to solder between here. And then we route a trace through them. So these are two techniques that you may need to use as you build slightly more complex boards in weeks to come. So the first thing we're going to do is we're going to actually just move this one part to the other side of the board to show how vias will work. So let's say I'm running out of space on this side of the board, or I want LEDs on both sides of the boards or whatever. And I'm going to take this LED here and I want to move it to the other side. So I'm going to go ahead and delete this trace. I'm going to select my thing and I'm going to hit F. So now it is on the back side, and I'm going to drag it so it doesn't intersect with my Arduino. And if I look in 3D, we can see what I've done. I've now, we can see kind of lightly the traces that we've added from before. And now on the back, we have our one LED, and on the front, we have another LED. Okay, cool. So if I look at the back now, so I'm currently looking at my front copper layer down. Now I'm going to look at the back copper layer and I'm going to flip the board. So I'm looking at it as if I was holding it in my hand. We can see I need to connect it, one, to ground. And we have conveniently these through-hole pieces that are ground on both the front and the back. So if we fill the ground plane on the front and on the back, it will all connect to one ground, which is this hole, right? So this hole and this hole both connect the front on the front side and on the back side of the board. And so as assuming that our ground touches both either of these holes, the front side and the back side ground will be the same. So it's very easy for us to connect ground of this part. We just need to fill everything and it will connect this ground, this hole to this hole on the back. And then on this side, if we fill the ground, it will connect to this hole on the front. And these holes are connected through the board. So we don't have to worry about ground, but we do have this problem where this pad is on the back and it needs to connect to this pad, which is on the front. It looks like I have a little bit of leftover trace here that I didn't want, so I'm going to delete that. So that means we need a via. So we can click this little via button, and now we get what will be a via, which just, this is not something that you're going to be able to make on the Makera by default. This is only if you send it out to a board house that can support bigger things. There are hacky ways to make a via, which we can talk about. But for now, this is just when you do more advanced multi-layer boards. We can add a via and we click, and now that little piece is both on the front and the back, right? So much like these holes that connect the front and the back, these will also connect on the front and the back. And we can, so you might do that and you would want to then connect this to this so that on this side of the board, the front side of the board, we connect to this little piece of copper that runs all the way through. And then we can switch to the back and we can wire off this trace and connect it over here. But what happens if we do that? So let's say we go to do our trace, we hit X, we click. It's not going to let me connect to this. And the reason is because this knows it should only connect to things with its name on its net, right? So you can see it's net D1K. And over here we have net D1K. These things need to connect together. And it shouldn't connect to this piece of metal because that piece of metal doesn't have that same name. So we can double click on it and we can assign it to that net. We have to unclick automatically update in order to find net D1K, which we then hit OK. And now it's the same. And now it's possible for us to hit X and wire them together. So now on the front, we connect to this. That will carry, this little via will carry the voltage through to the back. we can now hit X and wire this up around here. And now we have a two-layer board where we have a connection that goes through the board. So this is what using a via will look like. So it's kind of a pain in the butt to put the via down and then have to click on it and find the net. That's kind of a little bit of a pain. And so another thing you can actually do is go ahead and wire a trace out a little bit, and we can then click to install our via. And assuming our via intersects with a piece of copper, it will automatically get the name, inherit the name and the net of the copper intersects with. So that's a little bit quicker way. And generally speaking, you should drop your vias onto the traces that you're going to use them with when you take this approach. And then we can hit X and click and wire this up just like we did. And that's terrible. So we're probably going to want to, go into this track and move it around a little bit. Maybe delete this. Bring this in, bring this up, connect. It still looks a little off. There we go. Now it's looking a little better. All right, so we want to clean up our wires so that they look pretty good. So that's an example of wiring the front to the back here and using a via. The other thing I mentioned is you may want to connect two things on the same side and have one go under the other. And in order to do that, we're going to need some larger size resistors. So if we were going to do that, we would have to go back to our schematic. So I think I have it open over here. And I'm just going to, for an example, let's just say, let's do this. So let's say I need to route a trace under this thing. This is like in my way, right? So what am I going to do is I'm going to delete this. I'm going to add another resistor here, a R to rotate. I'm going to wire it up. And I'm going to change its value to 0 because I don't want this affecting my circuit. I just want this to basically be a wire, which is basically like a 0 ohm resistor. So now we have this extra 0 ohm resistor, but we need the footprint to be larger than an 0603 because in 0603, you're not going to route a trace under 0603. So we will look up resistor, and we have our surface mount components that get bigger and bigger. And I believe we have 1206 components for you to use as 0 ohm resistors, I believe. So we're going to make it this 1206 footprint. Okay. And so we've now added a 0 ohm, pretty large resistor so that we might be able to route under this trace. Okay. So now we will save this and update our PCB. Update, close. And you can see we now have a honkin' resistor here compared to these other ones. It's ginormous, right? And so we can drop this here. And now what have we done? You can see, so we can see this line connects here. And this line is going to connect, this guy connects A1, D2 to here. So D2A to here. So I'm going to delete this trace. And you can see I need to draw a line here and then a line here, right? So we may even just like grab these guys, move them over a little bit, grab this person, move it into place, and hit X to draw our trace. And now we've completed our circuit again. We've made basically no modifications to how it functions, but we now have this really big pass that we can go under, right? So now I could wire up X. I could wire up a trace like this. And go right through the middle of it. So this is a way that we can route when you get a more complex part and you need two things to go in different directions and they're blocking each other, which happens. You can use a really large 0 ohm resistor on a single-sided board. And this is purely a prototyping technique. You're never going to do this for like a final product, but it's really useful for prototyping something in our shop. So just keep this in mind. We have 0 ohm, 12 ohm, I believe 1208 resistors for you to use, and you can get away with doing this kind of a thing with them. Sound good? Okay, great. Let's move on to the board outline now that we've covered some advanced techniques.